Welcome to our channel. Let's begin the journey.
Today, we're diving headfirst into the dark. Literally. We are going to look at a daring scientific expedition into the eerie darkness of a total solar eclipse. An expedition that proved what is arguably the most mind-bending theory of reality ever conceived. We're talking about Arthur Eddington's 1919 mission to Príncipe, which proved Einstein's theory of general relativity by capturing a single, fleeting cosmic event. The sun's gravity physically bending ancient starlight. It's a moment that entirely rewrote the rules of the universe.
But to really understand the sheer magnitude of what we're about to explore, we have to start with a fundamental question. Is gravity just an invisible pulling force, or is it something far stranger? You see, ever since the days of Isaac Newton, the whole scientific world comfortably accepted gravity as a totally invisible force. A sort of mystical mechanism that somehow instantaneously pulled objects together across empty static space. And sure, Newton gave us incredibly reliable formulas to calculate that force, but he never actually explained the physical mechanism behind how it worked. That enduring veil of mystery, well, that is exactly what a brilliantly imaginative mind named Albert Einstein was about to violently tear away.
Okay, let's dive into this with Section 1, Redefining Gravity. The Paradigm Shift. Picture this. For a grueling decade, Einstein wrestles with immensely complex geometrical equations to basically completely redefine our universe. Through just extraordinary intuitive thinking, his boundless imagination brought these distinct concepts together into a single, flexible, four-dimensional fabric. He called this spacetime. So instead of space being this empty, static stage where things just kind of happen, Einstein proposed that space and time are fundamentally interwoven. They act as a physical, malleable structure that actually responds to the matter inside it. Think about the radical difference between these two paradigms. On the left, we've got Newton's universe, relying on that mysterious, invisible tether just yanking planets through an empty void. But on the right, in Einstein's universe, gravity is absolutely not a mystical pulling force. Not at all. Rather, it's simply the physical curvature of the space-time fabric itself. Imagine extremely massive objects, like our sun, creating these deep, sloping dents in this physical fabric. Because of those colossal dents, smaller bodies like the Earth aren't being pulled, they're simply sliding gracefully along the invisible curves created by that massive object. It's like a giant cosmic funnel. The whole mechanic of general relativity was beautifully and succinctly summarized by the physicist John Wheeler with this one phrase. Matter tells spacetime how to curve, and spacetime tells matter how to move. It's just an elegant, perfect cosmic dance. But as incredibly beautiful as this concept was, it faced a massive hurdle. Which brings us to Section 2, the need for empirical proof. Math versus reality. Because here's the thing, the scientific method is ruthless. It demands that science never, ever operates on belief alone. No matter how incredibly beautiful and mathematically elegant Einstein's masterpiece of a theory was, it was still firmly just numbers and equations on paper without empirical proof. Would the physical fabric of space actually bend? That's an incredibly bold claim. Science desperately needed a definitive, real-world test to verify it, because if Einstein was wrong, his entire decade of grueling work would literally crumble into nothing. So let's look at Section 3, the expedition to Príncipe. A daring mission. To truly appreciate this, we have to anchor ourselves in the world of May 1919. The globe was deeply fractured. We had just endured the devastating division and unprecedented bloodshed of the First World War. The human spirit was battered. Yet right in the middle of this heavily scarred geopolitical landscape, an exceptionally brilliant British astronomer named Arthur Eddington bravely steps forward to organize a daring scientific expedition. He knew that to prove a theory of this immense magnitude, he couldn't just look in a lab. He needed to observe the cosmos on its grandest scale. Eddington and his team pack up and travel to the remote, sweltering island of Príncipe, right off the coast of West Africa. Why there? Because they needed to intercept a highly specific, fleeting cosmic event, a total solar eclipse. Their core objective was to look right past the sun and capture the ancient light traveling from distant stars, positioned directly behind it. Moving to Section 4, Starlight in the Darkness, the Eclipse. This is where we leave the abstract math behind and step right into the high-stakes physical reality of the expedition. The setup was absolutely perfect, but the window of opportunity was terrifyingly small. Let's see how this builds together. The mechanical genius of this experiment breaks down into 3 simple steps. Step 1. Normally, the sun's glare makes it totally impossible to see stars during the day, but during the total eclipse, the sun blocks its own blinding light. Step 2. This is the ultimate test. If Einstein's radical theory was right, the colossal, overpowering gravity of our sun would physically act as a giant lens. It would noticeably bend the ancient starlight traveling from the stars behind it as that light passed through the sun's gravitational dent in spacetime. And step 3. Because the light's path was physically bent, the apparent visible position of those distant stars in the Earth's sky would actually shift slightly from where they should normally be. Imagine the scene. You're standing there. The temperature suddenly drops. The sky darkens in the middle of the day. Plunge deeply into the eerie, unnatural darkness of the total eclipse. The clock is relentlessly ticking. Tick, tick, tick. Second by second, Eddington and his team frantically work their delicate instruments, meticulously capturing these highly historical photographs. Everything, Einstein's entire legacy, the fundamental nature of reality itself, relied entirely on the faint smudges of starlight being captured on those photographic plates before the sun reemerged.
And that leads us to Section 5, a monumental triumph. The data reveals all.
The eclipse ends. The light returns. You can breathe again. But honestly, the real work was just beginning. Because after the meticulous data analysis of Eddington's photos, a truly shocking and definitive result emerged. Now, what's really interesting about this is the number, 2x. The ancient starlight was indeed bent, proving the sun acted as a gravitational lens. But it wasn't just bent, it was bent by the exact precise amount predicted by Einstein's equations. And crucially, that amount was exactly twice the deflection predicted by classical Newtonian physics. The data was absolutely undeniable. The physical fabric of spacetime really was curving. The scientific aftermath of this single observation was just explosive. Eddington's triumphant announcement turned Einstein into a global icon virtually overnight. His boundless imagination had been proven right in the real world. General relativity immediately stopped being just a theoretical curiosity and effectively became the core operating system of all modern cosmology. It directly laid the groundwork for humanity to understand massive, universe-altering phenomena, validating everything from the rapid expansion of the universe itself to the violent, bizarre existence of black holes.
But, beyond the incredible physics, there is a profoundly beautiful human element to this story. Eddington's expedition was a massive triumph for science, yes, but it was also a beautiful, necessary moment of healing. Just months after the unprecedented bloodshed of a brutal global conflict, here was a British scientist working tirelessly, traveling across the world to prove the theory of a German scientist. It affirmed so beautifully that the pursuit of scientific truth transcends all earthly borders, petty conflicts, and human divisions. Eddington's photographs proved that reality is vastly more bizarre than anything beyond our normal human imagination. He literally forced us to accept that the very fabric of our universe is a flexible, moving, dynamic entity. So I want to leave you with this final thought. If the simple mass of a star can physically bend space and warp ancient starlight, what other terrifying, beautiful, and completely invisible mysteries are quietly hiding in the dark of our cosmos, just waiting for the right scientific mind to bring them into the light? Thank you so much for exploring the fundamental nature of gravity with me today.
The view from here is breathtaking. Command, we are in position and ready for the next phase. If you liked the video, subscribe and comment the topic you want next. Thanks for watching, and stay unstoppable.